Well, good afternoon, everybody, and welcome to HRU 2023, despite my slide saying 2022. Um, I have a funny little anecdote. We usually call this month Checkuary, and Checkuary is where every check that you write, if you still write checks, you put the date as January 20 of the last year because you forgot to change over to the next year. Anyway, so I am Ria, and I'm N2RJ. I was licensed in 1997 in Trinidad and Tobago. Since 2001 in the United States and at the Kings County Theater Association in Brooklyn, New York. I do IT systems engineering, and I now do electrical and electronic engineering consulting. I've had a lot of ham radio experience, and my teachers taught me a lot of stuff. Of course, there's Silent T and Steve Mendelson up here in New Jersey. He was a big influence of mine. So if you hear a little noise, I'm actually at the Consumer Electronics here in Las Vegas, here on a work assignment. But I decided to take an hour to help out a great ham radio event, which is HRU. Because I'm proud to help the community. So just a little note, a lot of this is heavy on flex radio, but I have a few non-flex radio things that are actually quite cool, and I'll be talking about a couple of new things that we've been doing. So yeah, so stick around. And of course, nobody's paying for this. No radio manufacturer is paying for this. I do this as an independent observer. So I've enjoyed DXing ever since I was little. And, I enjoy radio for radio's sake. I really enjoyed learning so much about building a station, about propagation, about the world. And of course, learning about all sorts of electronics and digital signal processing, which is in software-defined radio. I also do some ARES. I've done ARES in urban environments in the city, and I've done a lot of home and kits. I do drone. I'm a commercially certified drone operator. They call it a remote pilot, but I think a pilot is somebody who climbs his own aircraft and flies it. So, but I have the FAA certificate to prove it. I do contesting, I do ride shoes, I do solar power and giant batteries, which is what I'm here for. So I'm actually here with the company that does solar power and giant batteries. What is an SDR? Well, a SDR is a software-defined radio. It replaces some or all of the components of a traditional analog radio, and it okay, yeah. It specifically deals with the RF components, like the detector and the modulator and such. And direct sampling basically sort of like grabs the RF out of the air, does a minimal amount of processing in the analog domain, and then actually converts it to the digital domain for the for further processing by software. Then you have baseband SDRs. They take RF down converted to baseband. Baseband basically is like a very low level, low frequency signal, and then it will do this processing in software. The difference between both of them is the direct sampling will use a specific hardware decoder that's designed to operate at higher frequencies, sometimes up to like 65 megahertz and maybe even higher. And whereas the baseband or Q quadrature sampling, halo detector ones, they do the RF down the baseband, and they use a sound card most of the time. So there have been a number of changes. I think the market's pretty much stabilized now. You have a number of them. There have been a couple new entrants, which I'm going to talk about. In particular, ICOM has been rocking some things here, but they've been around for a while. You have the traditional SDR manufacturers. You have Flex Radio, Apache Labs, Anon, which Apache Labs Anon is basically an open source project. Elecraft has a K4. If you ever go to ARRL W18W, I think you can have a K4 there that you can use if you're a member of the ARRL. Of course, if you're not a member of the ARRL, you should join the ARRL. And the ARRL does a lot of good things for ham radio. So what can the SDR offer? You can see the spectrum. You can get the best performance, and you know, everything could talk to everything, and of course you do remote operation. And we're going to talk about a few things that are a little bit outside the realm of amateur radio here. So here you can see the spectrum, of course, right? Every display has now a waterfall. Every ham radio now has a waterfall, so you can see everything. No big deal, right? Um, if you're in an AMCOM situation, you know, this is one that I like to point out, that some guys were like operating a hurricane watchnet in emergency communications, and it was forced to suspend operations because a broadcast station came blasting in the frequency. But you know, they could have avoided this by determining where the clear spot to operate on, and they do that with the visibility of an FDR. But they also have filtering to take care of strong nearby signals. There's something called a tracking notch filter in the flex radios, which works to filter that out. Let's talk about the performance. So in the analog domain, you typically have a lot of noise. You have a lot of internally generated noise in these things. You also have a lot of external noise from the environment. When these noise are in the analog domain, you know, when you have signal traffic in the analog domain, the noise could creep in. They could come in through the wires and cabling and interconnect. You could shield it pretty well, but that's basically like brute force. Whereas you're in the digital domain, you know, the analog signals will affect the digital bits, but since the digital bits are discrete states, meaning they're either one or the other, or they're not a continually varying signal, you'll find that any noise could easily be filtered out, because the noise typically, you know, back in primitively, you can actually you could take out analog noise by raising digital signals high enough so that anything analog, you just filter it out below a certain threshold. But now you have all sorts of things. You have artificial intelligence and machine learning that basically can figure out which is noise and which is signal. Okay. So Rob Sherwood, and I'm going to deviate a little bit from the script here because I want to show you something that the Sherwood chart has been changing over the years, and as he's been testing more radios. I think Yesu is still at the #1. I actually did an interview with Rob Sherwood on my YouTube channel. I'm going to check that out. It's somewhere there. But let's see here. Let me see the test video. Okay, so here you have the top dog is now, let me bigify this. The top dog is now the Yaesu FPDX 101D/MP. And these have like performance figures here that are pretty high. Now I'll explain these performance figures for you so that you're not totally lost. Of course, you know the noise floor basically is the lowest level that has noise, right? So it's basically, how should I put it? It's the highest peak of the noise where you're able to, you know, where signals will be above the noise. Agency threshold, automatic gain control. So this is where basically the automatic gain will activate, and you have the blocking, 100 kilohertz blocking, and we have the sensitivity, of course, in microvolts, local oscillator noise in dBc per hertz, and these are the spacing which are tested. Okay, they have this front end selectivity basically is the type of front end that they use to basically do some primitive filtering before they do it. Now, understand that when an SDR, now I'll explain this in a moment, there is usually some analog filtering before the digital. But the one we really want to look at, without going too deep, is the dynamic range narrow space. And this is typically what Rob Sherwood ranks these receivers at. Now, I asked him why he ranks it there. He joked and he said, well, you know, I just needed something, so I did that. But there's a very good reason. Typically, when you have a receiver, you want a receiver where you can typically operate it in crowded conditions. So you have a lot of people operating on a band, and you have a lot of people that are, you know, next to you with powerful signals. I mean, literally 1.5 kilowatts, and let's not kid ourselves. Some people transmit more power than that, right? I don't think I feel guilty of that. I'm not saying I transmit high power, but I transmit the legal limit. So anyway, um, the dynamic range, narrow space, basically means that if you have a weak signal next to a strong one, your receiver is able to basically allow you to narrow your filters and receive that signal without too much interference from the strong signal nearby. With an SDR in particular, you have like a wide band which you receive, and then because of that, you'll find that strong signals nearby in a wider pass band will end up affecting signals a lot more. But of course, SDRs have what you call a high dynamic range, so they're able to combat that. If you ever wonder what dynamic range is, if you ever watch a movie on DVD with a home theater system, um, so you have like normal dialogue levels in a movie, and then people be talking normal volume, and then something like a helicopter, an avalanche comes, and it basically shakes the whole room at very high volume. So that has very high dynamic range. Basically, it's the difference between the loudest and the softest sound. So basically, dynamic range is basically that difference. And it's important because you want to have high dynamic range in order to stabilize the level of the signal between in the presence of strong nearby signals. Right? Otherwise, you're going to be using this automatic gain control, and you're going to be going up and down to protect the receiver one. And what's going to happen is your weak signal is going to get churned down quite a lot. Okay. All right. So that was my little spiel on that. Let me go back to the slide. But anyway, oh yeah, so the receiver chart here, the dynamic range narrow space, the FPDX 101 is 110. This flex radio is 108. It's a flex 6700. Then you have other radios going on 107. Anything above 90, I think, is pretty much good enough for normal human ears and brains. You're not really going to get a lot more for that. And these radios here, at the top of the shelf here, you have the SDRs, you have the EAC FPDX 101, Flex 6700, the DX10, FT710. Yaesu is really doing some good stuff, I must say. ICOM R8600, and then you have this Elecraft K3S, which is kind of an SDR. And then you have ICOM IC7851, which is not an SDR, but it's a DSP radio, meaning that has digital signal processing in the IF state. You have Kenwood, and then you have the Tilberling, and the Tilberling is a $17,000 radio, handcrafted in Germany by Mr. Hilberling, and he, it's a very nice handcrafted radio, but it shows you the upper limits of super heterodyne technology. Okay. Yeah, so they have a lot of it. Now, what Rob told me is that he goes basically, he has a arrangement with a local HRO, and he goes and he gets radios, and he's able to do testing on them, and they basically let him do it. So the AWR lab does testing too, and you'll see like some of the measurements here. You'll have the same thing. Now they call this dynamic. They have a measure called RMDR, which is similar to the third ordered narrow space dynamic range. So it's basically the same thing, ability to hear weak signals among a and strong ones. So this is the caveat. So yeah, you have dynamic range, but with the SDRs, when you reach the top, because you're dealing with digital, you've reached the top and you're going to be clipping a lot worse than analog components. So with an analog component, you still have some wiggle room to go a little bit beyond the component specifications. Saturation is not really an absolute value. There's still a little bit of range at the top in kernel component spec. But digital basically deals with discrete states, and once you reach the top, you reach the top. There's still some tricks that they use to kind of stretch that a little bit. Like they might reserve a little bit of the top end. But how to combat that is manufacturers now have been putting analog filters before the ADC, analog to digital converter. They've been putting what you call roofing filters, and the roofing filters basically kind of filter out undesired signals, and then get you the signals nearby. Now, if you operate something like field day, what's going to happen is that you have a lot of strong transmitters nearby. You use external filters, use either an external filter unit or you use something called coax stubs, and the coax stubs are basically tuned. You tune them with a vector network analyzer, even the nano DNA you can use, and you tune those to frequency, and those will reject. Those will be band reject stubs, so they basically reject signals from other bands. Let's talk about the connected chat, right? And here you have a little. It's all dated now. I need to take new pictures, but I also need to clean up some stuff. I have a lot of stuff on my desk that I'm using and making YouTube videos and stuff now. WSJT is still going strong. Joe Taylor is getting up there, but he's still writing the software, and a lot of people are still using it. I know the last one on FT that I worked was Crozet Island, and that was my 329th country. Okay, so I'm well on my way to honor roll to get FTC. And then you have a login software that will integrate well. So instead of having a whole bunch of messy cables, you basically have one Ethernet cable, and you use software APIs to kind of to bind things together. So why does it matter? You can concentrate on your mission, and once you get once our application working, you usually get the others working. WinLink, as you saw the WinLink presentation earlier, and they're doing a lot of stuff with sound card modes. So the nice thing about these SDRs is that your sound information that are modulated by the software and goes through the radio, goes through a digital cable like a USB cable or an Ethernet, and then that will allow you to have a very clean signal path. Again, you're dealing with things in the digital domain. This one was, sorry, that slide is up over from Tuesday today. So less wiring, a lot of these radios have the USB connections now. You have Ethernet ports, right? Some of them, more of them will come with Ethernet ports. ICOM is coming with Ethernet ports. The ICOM 705, which I have now, is coming with Wi-Fi and Bluetooth, and that's a great little radio. It's my new favorite radio right now, to be honest. It's all about remote operation. So there's a few nice things about remote operation. You can't be everywhere at once, so you remote. I've been remoting on my phone. I work per se on my phone. I do a lot of DXing from my iPhone. I sometimes I don't even go into chat. For MCOM, it's also great. You can have a shift of operators operating a big station. Let's say you're doing net control, and you're talking out to a disaster area, like you're in New York and you're rendering aid to stations in Florida or Puerto Rico or something, doing the health and welfare traffic. You can have a nice strong station somewhere on the South Shore of Long Island, and then you can basically have the station remote in, and the operators can check in from all over via the internet to that radio, and then do the disaster. So essentially, the internet becomes your studio transmitter link. So this is my typical remote setup. I typically have my MacBook. Now I'm actually running MacBook Smart SDR for Macs and Smart SDR for iOS. So pretty good. Let's talk about a little more tools of trade. I've been talking about Whisper. You can use Whisper. Whisper is a JP thing, and you can even look at the CSA reporter to see, for population analysis. What can you get for $1? Well, you can't get anything. You can get a functional SDR receiver for about $21. SoftRock has been a really interesting thing. It was started by this guy called Tony Parks. And Tony Parks, he kind of retired. So he handed over the business to a guy named Ben Cherry. And Ben has been reviving a lot of SoftRock kits. One of the new kits that Ben is going to be introducing is for the really low bands, the 2200 and 630 meter bands. So you can, you know, you can experiment on those. He's going to have it kicked out soon. He's going to send me one free evaluation, and I'm going to be putting up the videos on the YouTube channel so you can take a look. I'm really excited. I have, you know, I've had antennas for 630 and 2200. I've been doing a lot of listening, and I've been doing test transmissions. So this should be interesting. There is also the red pitaya now. So red pitaya is a very interesting thing. Initially, it was designed as like an instrument, but hams have been using it for SDR lab for basically doing CW skimmer and all sorts of interesting radio things. So what does this have to do with SDRs? Well, if you watch my friend Josh's channel, the Ham Radio Crash Course, you'll see he's been playing around with this little thing called a Flipper Zero. And the Flipper Zero is based on SDR technology. So what it does is you can actually capture and replay all sorts of interesting signals. And it looks like a Tamagotchi, which is, those of you familiar with that, basically, I think Americans call it Gigapet or something like that. But it's a little thing with a button, and you have to feed the pet, and also it's a virtual pet or guide. But this one basically is an RF device. It has a sub 1 gigahertz radio, and you can actually capture signals. You can emulate all sorts of different signals. You can emulate RFID for like, you can, you know, like smart cards, which is why when I'm walking around here in Vegas, I don't know who has one of these. So I put all my hotel room keys in a little RFID proof bag. I'm not, you know, I'm taking chances with that. Those who know my background from information security and hacker conferences, you know I'm very security conscious about that. So yeah, the Flipper Zero, Josh has been using it. He showed some things about opening the Tesla chart doors. You could use it for all sorts of replay attacks. You can even capture rolling codes and replay the sequence, although they're software limited to prevent malicious use. So this is based on SDR technology as well. The ICOM 905, it has the VHF UHF, and this is a very exciting radio because it's a brand new concept, and I think I put some pictures of this here. So this, believe it or not, is a radio, right? You have a module that actually sits on an antenna mast, and the actual radio and amplifier is up there. So you have that up there, and the radio is up there, and then you have the connection to the actual control head, which looks like an ICOM 705, and that connection is basically over Ethernet. So what happens is the ICOM 705, well, ICOM 910, it will supply power to this radio with power over PoE, and then it will send digital data up to this radio, and then it will send the radio will have a very short line on the RF side, on the air interface. So basically, you have you know, very small losses. You have your antenna. You can put a 10 gigahertz dish or something, or you could put it has 2.4 and 5 gigahertz as well, and it has I believe it has 2 meters and 70 centimeters as well. So you have these up here, and you're able to basically do microwave band SHF, you know, and it's great because it makes this a lot of more accessible to a lot of people in terms of, like, you know, you don't have to build transverters, you don't have to buy transverters and stuff like that. So I'm hoping that opens up a new thing. And you could put this in a backpack. You then have like a pole you take out your car, and then you you know, you can use that to go on top of a mountaintop and work some signals. You know, I've done that with Andrea KTEZ, and she, you know, we've had a lot of fun. I was surprised from like Pennsylvania, I could work people down in like Virginia and you know, with all the enhancements, you could work people far away. Let me see. You know, what Ray Novak is telling me is that, you know, yeah, it's basically it's a familiar interface that people don't have to relearn, so they kept it simple. Of course, I'd imagine there's some advantages to tooling and stuff like that, that in the factories they would be able to minimal, not, you know, they don't have to spend a lot of money developing new molds and all sorts of stuff like that. This is a little thing. This is a true SPX. It has like a payload detector and stuff like that. So it's a little nicer project DLT on the end, P1 ends. Yeah, so I throw that in there. It's a little thing based on QCX. We have more RTL SDR, and RTL SDR is still going strong. You know what? They even sell it at Micro Center. You can go to Micro Center, you can buy an RTL SDR. They have it from Adafruit. Adafruit sells a kit you can buy. But this one is the DX Patrol. Basically, this one has the built-in down converter. Now, the thing about RTL SDR is that these are originally European DVD TV tuners. And what happened is you needed to use an up converter to fuse these with HF. But some of these basically package the up converter and the SDR together. And you'd have the converter built in. I talked about the reverse beacon network. Reverse beacon network would not be possible without the use of SDRs. And it's very good to know if you're getting out, right? And you can tell whose signal is bigger. Yeah, and I tell you whose signal is bigger. So I looked at myself, and I looked at K1ZZ, and I looked at K3WW. Those who don't know who K1ZZ is, he is a former CEO of the HRU. He's a longtime CEO. And he has a big station in Coventry, Connecticut. And, his signals, sometimes my signals exceeded his. And sometimes his signals exceeded mine. But, Jay. So anyway, I have my YouTube channel. If you guys want to, follow along, you can go to youtube.com/@N2RJ. And I also do a weekly radio show on WTWW shortwave. Actually, it's not WTWW anymore. It is WRMI Legends, because we're now on the fabulous WRMI stations down in Lake Okeechobee, Florida, and broadcasting to the world. I believe we're on 4980 kilohertz. My show airs every Friday at 6 p.m. Eastern, 5 p.m. Central. So, you could check it out. And with that, I guess we could take some questions if you guys have questions. George?
Okay, let me come in for a second. Hi, everybody. I'm George, N2RJ. There's a questions tab on your control panel. There's a pane that says questions. And if you click on the little arrow next to it, it will open the pane and it'll allow you to ask a question. I don't have any questions at this time, Ria, but possible someone may ask a question while we're waiting. So if you have anything else, you might as well make your comments now.
It's a little chilly here in Vegas, believe it or not.
Well, apparently we don't have any questions. So, oh, here we go. IC 905, do you know if it's water resistant?
The IC 905. So I believe it is not like submersible. The ICOM 905. I said it was a 910. I apologize. It's a 905. It might be water resistant, but I wouldn't count on it being waterproof. But actually, the radio module itself is not the control head. The radio module itself is.
Okay, another question. Are DV sticks safe for indoor use?
DV what?
It says DV sticks.
Oh, the DVB sticks. Yeah, they're safe for indoor. Yeah, they receive their. You can use them indoors if you have antennas that'll operate indoors. That'll work too.
Okay. Anyone else have any other questions?
So the 905 actually. Yeah, the 905 we did. ICOM has been bringing around to Handfast. I think probably if you're going to Orlando, you might see it there. So if you want to stop by the booth and ask Ray Novak, he'll show you. He'll demonstrate it to you. I might have a video up on it on my YouTube channel too. So. Actually, you know what? I did actually have a video with Ray talking about the 905.
I think there'd be one there. I think that's something that they would show.
Okay.
Don't have any other questions, Rhea.
All right. Well, look, I'd like to thank you for attending, and I hope you learned something. Have a great
Okay,
day.
thank you very much. Thank you very much for your efforts on behalf of Ham Radio University.
Thank you.